Hello everyone, it's Dominic Ransberg with the Reeducation Project. Today here we are starting our second series. The first series was about sources of infinite energy that our government ultimately hides from us. This new series is going to be about sources of anti-gravity technology that they hide from us that we can ultimately use to travel outside of our solar system. I want to give a big shout out to Zeg TV, Lancaster Online, and Harvard Natural Science Lectures. What we're going to be getting into here first is quantum locking, and then next we're going to get into a beam ship using gravity control propulsion, and then we're going to get into acoustic levitation. Okay. First, as I stated, we're going to get into the quantum locking, and basically what that is you use superconducting materials and you sandwich them between layers of gold and sapphires, and then you dip that in liquid nitrogen. So check this out.
This is Jim Ringline. I'm the Curator of Science here at the North Museum of Natural History and Science in Lancaster, PA, and we've got a really great demonstration that we'll be sharing with the public, particularly this coming week between Christmas and New Year's here at the museum. The idea is that this superconducting material floating above magnets is really nothing new. Well, what's special about this crystal is that the sapphire itself has a crystal structure that keeps it stabilized when it's doing this kind of thing. So from its creators, they call this quantum levitation. And the reason that they call it that is because it's got a peculiar quantum effect related to the sapphire crystal that's in this. So first thing that I'd show you here is this is really the dynamic element of this that's been created by this group in Tel Aviv. This is a disc that has gold on one side. You can see the gold. It's really, the gold is just a protective coating on there. And then you can see on edge that it's very thin. And in the thin layer are two very important components. One is a superconducting material, and then the other one is a sapphire crystal. And what we do with the superconducting material is we've got to cool it down to liquid nitrogen temperature, which is really cold, only 77 degrees Kelvin. And the way we do that is we put together this little package, which is what I'm going to do right here. So we take a foam disc. There's nothing special about this, just a foam that I'm going to put on top of this right here and make sort of a covered disc out of it. I'm going to pour liquid nitrogen out into a container. We're going to put this disc in there. The liquid's going to get inside of here, get in with the foam and the other crystal materials, and then it will make it very cold down to the temperature where the superconducting material will really become superconducting. Take it out now, the excess liquid nitrogen out of it. I'm going to take a very strong magnet over here, put it right over top of it, and you can see that it floats. Now the interesting thing about this is having things float above other magnets is not that unusual. A lot of people maybe have played around with magnets floating on top of other magnets, but what's unusual about this is how particularly stable it is. I can twist it and twist it like this, and it stays there. It doesn't want to rotate or jump around like other magnets would if they're up on top of other magnets, because it's not really a magnet, it's a superconducting material. I can even do this, I can even turn it over. Now, one of the other things that's really interesting about this is this one stays pinned any orientation, and if I try to twist it, it doesn't really do anything. But if I take it and I put it over top of this particular magnet here, now I can make it rotate. So I've had this out for a little while, so it probably has a little bit of coldness left to it. We'll see if it stays floating on there. I give it a spin, and around it goes. Now this track here, as a whole, the whole thing looks circular, but each one of the magnets points inward just a little bit. So that's what enables this thing to oscillate or go around this circle here in a circle, because it's got a magnetic field that allows it to do that. The Quantum Levitator will be here every day next week between December 26th and the 30th at noon every day, and on Monday, Thursday, and Friday we'll also have it at 2:30. So a 2:30 program, a noon program, about a half hour more or less, and you can see this thing live in person here at the North Museum of Natural History and Science in Lancaster.
Okay, so next what we're going to be looking at is this beam ship demonstration. That's what the guy calls it. I don't know his name exactly, but the video will be linked. Check this out.
I'll give you a little flight demo of Beam Ship Variation 1. I designed this way back in spring of '02, and it also won the Detroit Metro Science Fair. It won the Detroit Metro Science Fair Grand Prize in Physics. in spring of '03 for 3 Dearborn, Michigan high schoolers. Anyway, I'll just give you a little flight demo of the Variation 1. Now, that'll go up as high as you want. We keep it lightweight for safety, so we don't have to feed in a lethal amount of voltage, basically. That's floating on probably about 30,000 volts, anywhere from 25 to 30,000 volts at about 1 to 1.5 milliamps, something like that. Not a lot of wattage. Not a lot of wattage, less than 50 watts, something like that. It's high voltage, low amperage. But what happens is, this top wire that runs all the way around the device, is this coming through okay?
The sound is coming through, yeah.
Okay, yeah, the top wire is called the anode. That's charged normally positively. The foil skirt is what is basically the flying saucer. That is the cathode. And what happens through Coulomb's law of electrostatic attraction, the cathode wants to fall into the anode. The higher the voltage, the more the force. And the greater the horizontal force, vertical force, whichever way it's oriented, it will go. And of course, oriented away from the Earth's surface, that's the direction which we call anti-gravity. But it's really not anti-gravity per se, as much as antimatter is the opposite of matter, opposite spin and charge of normal matter. It's developing an artificial gravity field in 180 degrees opposition to the Earth's gravity field. Now, what's powering it is this little power supply here. We call it Power Supply Alpha. We get them from Information Unlimited. They make it for us really cheaply. And that's this unit here. It's really no larger than a pack of cigarettes. I have it propped up against this insulator here, and it's running off a 12-volt Radio Shack power supply. I could later, if you want, show how it runs with a lithium-ion battery. I have a lithium-ion battery of the type that's normally used with electric radio-controlled cars, planes, and helicopters, that sort of thing. But anyway, in this state, it has no inertia. It has no g-forces. It can go from 0 to 2,000 miles an hour with no perturbation. If you were inside, you'd feel nothing. Every atom of ship and payload within this electrical field responds at the same rate to the applied voltage. And that's what's happening. There's no thrust coming from anywhere. Got to make sure not to touch the ground wire. You'll feel like a cool wind, but that wind is nowhere near strong enough to lift the device by about, the U.S. Army said, about 3 orders of magnitude. If any of you are scientists, you know how much an order of magnitude is. So this is just floating, and it'll go up as high as you want, as fast as you want. There are about 5 factors that determine the efficiency of the Biefeld-Brown effect. Number 1, by increasing the voltage, you increase the effect. And the effect is exponential with increasing voltage, so that's quite a bit. Number 2, increasing the area of the capacitor plates. If you increase the capacitor plate area, you get a much greater effect. And that's what I found in my data table, which I'll read off to you later in my paper from New Energy Technologies magazine, or actually journal. The dielectric, if you have a higher K-factor dielectric between the anode and the cathode plate, you'll have a much greater effect. Air is maybe hardly any dielectric effect at all. You could use barium titanate and get a much higher effect. I think I'll turn this off because transistor is getting pretty hot now, by about now. See, it is a heavier than aircraft. Another factor which increases the effect is increasing the mass of the dielectric, and there's your connection with gravity. You have more atoms doing the work, increasing the force even more. So basically, when I was young, I was interested in UFOs all my life. When I was a kid in the 60s, UFOs had only been a phenomenon for since World War II, about 20 years, in 1967, when I was in the first grade. But I was interested. I thought, how could they just fly with no propellant? How could they fly so fast? How could they fly without any noise? How could they hover and take off? It seemed like they were making fields of artificial gravity. But in the physics literature that I was aware of, there was no way of generating a gravity field. Well, little did I know, in 1982, I came across this work, which was, if any are familiar with the Billy Meyer case and Wendell Stevens, this is book UFO Contact from the Pleiades. It's published in 1980. there's a section on how they could travel here, how the Pleiadians or Pleiarans could travel here at such incredible velocity. Well, it's not really incredible velocity as much as it is a shift in space-time, but we can duplicate these power sources. I saw David Froning, H.D. Froning, works for McDonnell Douglas, or did work for McDonnell Douglas, he's retired now, at COFI 3 in Washington, D.C., way back in October of '09. And in here, in this book, UFO Contact from the Pleiades, he details a paper with, any of you know Boolean algebra, how we can get to the Pleiades or any star system in reasonable time and economy. Talks about the investigation of a quantum ramjet for interstellar flights. And this is for the AIAA SAE ASME 17th Joint Propulsion Conference in July of '81. And he talks about with electric propulsion, field effect propulsion, we could be liberated from our own solar system and explore other planets, other stars, other galaxies, anywhere we want to go, any speed we want to go. There was also a paper by Alan C. Holt of the AIAA and NASA on how we can travel with starships, with lasers, laser-guided ships, to any planet. And this was his paper, Alan C. Holt's Prospects for a Breakthrough in Field-Dependent Propulsion, AIAA 80-1233, NASA Johnson Space Center, and that was June 30th, July 2nd in 1980 in Hartford, Connecticut, Joint Propulsion Conference. And he talks about a field-dependent propulsion system that is pretty much a clone of this, and using lasers where they can exceed light speed by many times over. And since this system has no moving parts, no inertial mass is canceled on this. You could go any speed and your inertial mass doesn't build up. What that means is, with no inertial mass buildup, the speed of light shouldn't be a barrier any more than the speed of sound was a barrier to Chuck Yeager in his Bell X-1.
Okay, so now what we're going to be getting into is acoustic levitation, and that's done by reflecting sound waves off of a solid object. Check this out.
I'd like to show you an example of levitating small objects with sound waves. Let me just remind you how a loudspeaker works. It's just a diaphragm that repeatedly pushes on the air, producing high pressure waves that move away. And that's what we have here with this little gizmo. It does the same thing, except it's at a very high frequency, 28,000 hertz, which is way above our human hearing range. So these sound waves move upward, and up above I have a glass plate which is going to reflect the sound back down again. And when the distance between the glass plate and the loudspeaker is just right, then those sound waves that are moving down will interfere constructively with the sound waves coming up and give us regions of high pressure and low pressure which don't move around. They stay in one spot. And it's in those high pressure zones that I'm going to try to levitate a small ball. So let me turn on the power, and even though I can't hear it, I'm still going to use ear protection. As I said before, the distance between the reflector and the loudspeaker is just right. If I change it, and which I'm going to do, you'll see that this standing wave disappears and the balls are no longer suspended there.
I'm Dominic Ransberg. Thank you for watching. If you haven't already, please subscribe. And if you haven't also liked this video, please do like it.